Hi everybody and welcome to chapter 4. Can you believe that we're already on chapter 4? Exciting stuff. Okay, so what are the objectives of the chapter? We're going to talk about discrete probability. We're going to talk about expected value, the binomial probability distribution. We're probably going to skip these last three just because of time. But we'll see how far we get. But I don't necessarily think we're going to cover these. We're just going to do the very basic ones. So let's get into it. So 4.1 talks about probability distribution function for a discrete. Remember, discrete is countable, things that we can count, random variable. Okay, so a discrete probability distribution, right? So remember, the function itself has two characteristics. Each probability is between 0 and 1 inclusive. So the probability, so that's normal, right? We already knew that probability values are between 0 and 1 and could include 0 and could include 1. The difference, and this is actually the sum of the probabilities, all of them need to add up to 1, okay? Because it considers all the options. So this is best illustrated with an example. So let's suppose you have a child psychologist interested in the number of times a newborn baby cries, wakes his mother after midnight. So how many times does the mother wake up to hear the baby's crying? So we randomly ask 50 mothers, and we got the following data. So let's X be the number of times per week a newborn baby crying wakes the mother after midnight. So for example, the baby could wake its mother 0 times after midnight, 1 time after midnight, 2 times, 3 times, 4 times, or 5 times after midnight during the week. So let's suppose P of X is the probability that this could take on some value, 0, 1, 2, 3, or 5. Okay, so look at this. So what is this saying? So out of the 50 mothers, right, the probability of them being woken up 0 times, that's 2 out of 50. So 2 mothers out of the 50 mothers slept very well that week. 1 mother, no, so this number doesn't mean the mothers, this means the number of times they were woken up. So 11 out of 50 mothers were awoken? Oh geez. were interrupted after midnight once, okay? 23 of the 50 mothers heard the babies cry 2 times after midnight. 9 mothers out of 50 were woken up 3 times. 4 mothers out of the 50 were woken up 4 times, and 1 unfortunate, unlucky mom had to wake up 5 times out of the week after midnight because her baby cried. So this is it. So this is basically the structure of it. Now each probability is between 0 and 1, check. And if we add all of these up together, we get 50 out of 50, which is equal to 1. Okay, so let's do another example. So a hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. So this is also a 50 patient situation. Let X be the number of times a patient rings the nurse during the 12-hour shift. So the patient either rings the nurse 0 times, 1 time, 2 times, 3 times, 4 times, or the max 5 times. So why is this a probability distribution function? Okay, so let's make sure we understand what happened. So out of 50 patients, 4 out of 50, 4 of them did not ring the nurse at all, 0 times. 8 of them, 8 out of 50, rang the nurse once. 16 out of 50 rang the nurse twice. 14 out of 50, 3 times. 6 out of 50, 4 times. 2 out of 50, 5 times. And what happens is this basically takes care of everyone. If I add all this up together, what do I get? I get 1, right? So these are the two. These are the two requirements, right? Or the two properties of a discrete probability distribution function is that each individual probability is between 0 and 1, check. And if you add all of them up, you actually get the number 1, also check. And that's it pretty much for 4.1. Here's your super fun homework, and I will see you in the next video.